All right, I think we're ready to get going. Good morning. Welcome to day 38 for the online Rankin Technical College AWD 1000 Web Development Technologies class for fall 2023. As mentioned here, what we're going to do today is we're going to go over chapter 5, which is a very short chapter. All right, and it says I will go through the debug JavaScript tutorial. Well, we're going to talk about this. How's that? And I've got a worksheet. I called it a pretest. All right, that I sent out a little later this morning, sent out just a bit ago. So we will go over that as well. Tomorrow will be a lab period, and we'll go over this worksheet / pretest on Monday. All right. Again, your chapters 4 and 5 homework is not due until a week from Sunday. So technically, you don't have I don't think you have anything due this weekend. All right, that said, I'll be doing a lot of grading this weekend. I was caught up, but I haven't graded anybody's test yet. So I'm going to do that. And any other homework that people have turned in, I'll be grading as well. A couple people have asked me, they've said, hey, if I finished 40% of the homework, how do I let you know that? Well, if you get a message back that you're done with 40%, just take a screenshot of it and email me the screenshot. That's something like that is just fine. All right. Okay. Now we're going to do this a little bit differently. And what I mean is the first thing that we're going to do today is we're going to watch a video. It's only 7 minutes long, but it's really well done, I think. And it's on Chrome DevTools 101. Then we're going to talk about it afterwards. So I'm just going to put this on and let it play. Like I said, it is about 7 minutes and 27 seconds long. All right. So what I sent you this morning, just so you know, is I sent out this, and I call this the pretest. All right. So it says complete the following. Reread Muroc chapter 5 is necessary. We're going to go over chapter 5 in a couple minutes. This is what we just watched right here. If you wanted to go through it again and actually have the code up that he used, which is simple code, that's right there. All right. Then you can kind of read what's here. So this is the Chrome Tools documentation on DevTools. All right. This is the Mozilla documentation on sitting and working with basically being able to do breakpoints. This is the W3 schools thing that's in there working on breakpoints. And this is a thing I found from Stackify that talks about JavaScript debugging. So what I want to do is I want to now go in and take a quick look at what is in chapter 5 in your book. So that was just a little prelude, so to speak, so you can see the kind of stuff that we're talking about. And I'll mention, because they mentioned a few things we have not yet talked about, so we will very shortly. All right. So chapter 5, as you can see, starts on page 161. As they say, as you build a JavaScript application, you need to test it to make sure it performs as expected. Typically, when you test it like that, so let's say, for example, with our calculator, the one that we looked at yesterday, you just try a few problems that are fairly simple problems and make sure that that it adds correctly, subtracts correctly, multiplies correctly, divides correctly. Well, you also know that, for example, with the divide, that we have a special thing in there that if you try to divide by 0, that it should come up and it should say for the result, illegal divide by 0. So at a minimum, that's the kind of thing that you're going to want to test. All right. So, again, when you run through this, usually the first thing most people do is to try to make sure that the simple stuff, works as you think it would. All right. So we'll get into that in this introduction. Then, as you can see, they only talk about this for a few minutes or a few pages, the Chrome developer tools, and then some other debugging methods. Like I said, this won't take long. All right. We may be done today closer to 9 o'clock. All right. But we'll talk about that when we get to that point. All right. So as it says, when you test an application, you want to make sure that it runs correctly. Now it says, as you test it, you try every possible combination. Well, it's probably almost, when you think about it, it's either very hard or next to impossible to check every single possibility. But as an example, all right, and I'm just going to put this up here real quickly. When you think about what we did with one of the first examples that we went through in here, we did that BMI example. All right. And you were supposed to be able to put in a height, and that height had to be between 12 and 96. You were supposed to be able to put in a weight, and that weight was between 1 and 777. So at a minimum, you want to check, as an example. I want to see, and I know there's no one that's 12 inches long that probably weighs a pound, but you would like to check what I call the fringes. So you want to make sure 12 is an acceptable height, 96 is an acceptable height, 1 is an acceptable weight, and 777 is an acceptable weight. You also want to test things like, for example, 11.9. If you're using a parse float, and if it's a parse int, you want to check 11. In the same way, again, if you're using a if you're using a parse float, even try 96.1. And if it's a parse int, try 97. Make sure those fail. All right. And a similar type of thing here with weight. You want to make sure that if you put in a weight that's under a pound, that it's handled, that if it's over 777 pounds, that it's handled. All right. So again, those are basically, for lack of better words, those are range validations. So that's what we're doing right there. Then you want to check, because remember that once you start to put in valid values, you've got 4 different possibilities. You've got underweight, you've got optimal weight, you've got overweight, and you've got obese. And you want to check those as well. And if you remember, for example, with underweight, that should have been less than 18.5. All right. When you check for optimal weight, it was greater than or equal to 18.5, and it was less than 25. When you check for overweight, it was greater than or equal to 25 and less than 30. And when you check for obese, it was greater than or equal to 30. So you want to hit all of those. All right. In addition, and I'm not going to type this in or anything, but in addition, remember that we were also doing counters. So at a minimum, once you start to do this and it appears to be okay, you want to do it. And I think I did this for you when I tested it. You want to put in 1 underweight, 1 optimal weight, 1 overweight, 1 obese weight, and make sure that your counters are all 1. All right. Now, why am I even telling you this? I mean, it's like, should you care, etc. Well, if you remember, the one of the things that you were supposed to do for chapter 2 homework was that fast food thing. All right. And we came in there and we did this. We said const burger equal $1. All right. Then we said const fries, and I think that was $2. Then we had a const sodas, and that was equal to $2.50. All right. Those were our constants. And then you read in the number of burgers, the number of fries, and the number of sodas. Okay. Yeah. Pretty obvious. All right. But then when you were figuring out the cost, it was something like this: total cost equal, and it was like burgers times burgers plus, and I'll put it on multiple lines just so you can see everything, plus fries times fries plus sodas times sodas. So for example, if you were running it, and let's just assume for a second that I'm going to put in here a 2, and I'm going to put in here a 1, and I'm going to put in here a 3. All right, just for testing, simple testing purposes. Well, what does that say? 2 times 1 should give me 2. Pretty obvious. All right. 1 times 2 would also give me 2. And 3 times 250 should give me 750. So in other words, you can do that simply yourself and find out that it's 1150. Okay. Now, I'm not putting anybody on the spot. I'm not going to say a name, but I had a student who sent me an email the other day, and theirs wasn't working correctly. And one of the errors that they had in their program, and I don't even know if they knew they had the error because they weren't getting that far in their code, but they did this. So instead of using the constant, which was 250, they used the variable, and that's whatever you read in for your number. All right. So in other words, if we had this 250 and that was 250 times 250, instead of 750, it would give you 625. Now, that is what is referred to as a logic error. All right. Why? Because as far as the system is concerned, you did nothing wrong. All right. And unless you find your own error through testing, all right, and get the bugs out through debugging, All right, you might put it in there and it might just be wrong. Now, if you do this, you're going to get a different error. All right, I left the T off of the word const. All right, and what does that do? That is referred to as a syntax error. Normally, it'll show when you bring that up when you're in Visual Studio Code. All right, but not always. Let's take a quick look, and I'm just going to bring up one of the problems that we've done. So if I can find it in my mess here, well, you know what? I'll bring up the calculator. All right, so let's bring up the calculator and let's purposely introduce some errors into it. All right, so I've got, this was the one that we did first. All right, so when you look in here, right now it works, but let's make it not work on purpose. All right, I'm going to take my calculator 2, and I'm going to make a copy of it. All right, so I can go and revert back to that later. But I'm going to bring this file up. So let's bring the whole solution here up, calculator. Let's bring this up in code. All right, and I'm going to go over to calculator 2 right here. So there's my calculator 2. All right, here's my index 2. So they're both here right now. I'm not worried about CSS. All right, now let's talk about some common errors that people make. All right, well, notice that when we did these, we called this num1 and we call this num2. That's pretty obvious, I'm sure to all of you. But let's say that in here, when we were doing this, when we were setting these up, we put in here, for example, number 1 and number 2, all right, which is wrong. Okay, so I'm going to save this and I'm going to run it. And now I'll put in a number, an operation, and a number, and nothing happens. This kind of thing has probably happened to you before. When that happens, then what you should immediately do is right mouse click on an empty part of the form. The author says you can also hit the F12 key or do a Control-Shift-J. To me, the easiest way is to right mouse click and choose inspect. All right, then it breaks your window in half, so to speak, and you go over to console and it tells you. All right, sometimes the error is very good, sometimes it's not. Now it says here failed to load resource. This usually is a favicon thing, and that you don't have to worry about. But it says here calculator 2 JS line 5. If I click on it, notice what it's showing me. It's trying to show me there where my error is. Now you might look at that and go, there's nothing wrong with saying dot value. The problem is right here. All right. Now, one of the things that they talked about in that video that we just took a look at is you can come into here and there's different things that you can do. We're going to look at that in just a moment. All right. Now, yesterday when I was going in and I was showing you possible errors with this stuff, when we were going into it, if you remember, I put some alerts in, which is totally fine. All right. If you don't want to put in alerts, okay, you can also put in console.log, console.error, or console.warning. What's the difference between those? A console.log is supposed to print up when you go into the console right here. All right, that's what's supposed to show. Now, it just shows black text and whatever. I'm in the console now. For instance, I can do math in here if I want to. All right, I can actually write JavaScript in here if I want to. Now, if I do the console.warning, I believe it comes off in kind of an orangish sort of color. And when I do a console.error, it looks more like this. It's more reddish. So instead of what I did yesterday, when I came into here, let me go back here, all right? And if I know I've got an error in here someplace, I could always come in and say here, console.log num1 equals plus num1. All right. And I can do the exact same thing with num2. All right. And again, I'm going to come in here and do a file save all, and I'm going to run the program again. All right. And I'm immediately, well, let's just introduce the error. All right. And I'm going to come into inspect. All right. And I'm going to go over to console. All right. Now, if I do come in here, it looks like it didn't print, but if I come in here and type in num1, all right, it says, oh, that's what we called it. How about number one? All right, it says number one is not defined. So you can see everybody learns to debug in a different way. All right, I will tell you that to me, the debugger that is built into Chrome DevTools here is not nearly as nice as the one that we use. Those of you who took the C# class last semester, their debugger in Visual Studio is much better. Those of you who will take it in spring, their debugger is much better. But notice it says number one is not defined. Well, you could see that num1 was set up, all right, and number one was not. So if we go back to our program again, this would be kind of a silly way to do it, but just so you see it. And now I'm going to come back and say num1. All right. But what I'm going to do here is I'm going to leave number two so it's still incorrect. Now, again, I realize that's not typically what you do, but let me open it again with live server. I still get an error. I go into inspect. All right. I go over to console. And again, look what it has here. Cannot read properties of null reading value. It's trying to help you here. It's showing you there. It doesn't understand something because there is no value for a variable you have not created. All right. But again, if I come in here to console, now if I type in num1, num1, and I hit enter, all right, and I type in num2 or number one now, number one, all right, I get the same error. All right. Let's go through and take a look at what they show in the book. They're probably going to illustrate it better than I did. But what I'm trying to show you, what I did show you, were the three basic types of errors that you can get. And those three basic types of errors are syntax errors. In fact, I didn't show you one. So let's very quickly go into that. So I'll go back here and let's fix our error. So we'll make this num1. And it should work now. In fact, that's num2. All right, but let's spell value incorrectly here. That's a syntax error. Again, I don't think this is going to work. All right, you must input a number. It's like, wait a minute, I inputted a number. All right, so I inspect again. I go over to console, and it looks like, geez, what's the problem? This is the hardest one to find. And notice it just says index 2, line 59. Well, that's not even my stuff. That's system stuff. So what the heck is the problem? Like I said, these are the hardest ones to debug. Because when that's the case, you've got to go back. And if you think the problem could be in your HTML, you look in your HTML. And if you think that the problem could be in your JavaScript, you go into your JavaScript. All right. You probably will end up going into both of them. But when I look here, it's like, wait a minute, this is what came up. You must enter a number. Well, I've got a num1 here, and I've got a num2 here. Well, hopefully then you recognize something like that. All right. So that is a syntax error. Now, because of the fact that JavaScript is such a forgiving language, not putting a semicolon on the end isn't going to 99.99% of the time, that will not cause an error. All right. It'll just basically they put in what's referred to as an implied semicolon. And if you remember when we first started on this unit, I had semicolons turned off and everything was still working just fine. All right. So there's syntax errors. There are runtime errors. Now, not in JavaScript. In fact, if you look at this, all right, this the way that this is set up right now. That's actually doing what we've asked it to do. Illegal divide by 0. If I would not have put that check in, this would have still worked, but it would have said infinity. JavaScript is one of the few languages that I know of that if you basically try to divide by 0, you don't get an error. Now, this is something you're going to learn a little later in this book, but I can introduce it now. When you've got an error in virtually any kind of programming language, it's referred to as an exception. And an exception means something that is different from the norm, so to speak. All right. I mean, if I'm sitting there walking and if I take my grandson for a walk, all right, he's 2 months old, but if he's in his stroller and I take him for a walk and somebody says, wow, what an exceptional child, I'll probably say thank you. All right. But in programming ease, when an exception is thrown, typically it's because there's an error condition and it causes the program to stop right there. All right. There's other kinds of things that can happen too. Like what? Well, what if I write a program, and we haven't even dealt with this, so don't worry about what it means. But it is possible in JavaScript that I can go out and I can read information from a file. So let's say that I had a file, just a simple text file that had, let's say, my 5 favorite songs on it. All right. And I put those 5 songs in there. I save it as songs.txt. All right. But when I go to read it, instead of typing in songs.txt, I accidentally type in song.txt. So the system goes out and it attempts to read a file called song.txt, which doesn't exist. So what's going to end up happening is I'm going to get some kind of a file IO or input output exception, and the program's going to stop. That's another example of a runtime exception because I don't discover that this is an error until the program is actually running. All right. And the third type is what I showed you a little bit earlier, and that is the logical error. So again, with that, let's assume, for example, that I'm not paying attention and I'm doing a lot of copy and paste. So I go and I copy everything that's in here for my subtract. I copy it in here. So I've accidentally got that. I change this to multiply, but I don't change this. All right, let me save. Let me run. And it's pretty easy, simple typically to find out. I'll put in 67 times 9. When I do that and it comes back 58, that should send me a signal something is screwed up here. Not only that, it should be actually probably simple enough to figure out what the problem is. All right. Sometimes when you do this stuff and you have an error in your code, sometimes you know right where it is. And the more you do this, the better off you get at it. All right. I was talking with my former boss before I came to class here, and we were talking about people, and the only way to get good at programming is to program. You're not going to get better at programming from watching my lectures. You're going to learn the most from you sitting down and doing things. All right. And sometimes the worst thing that can happen is, all right, you go and you do an assignment and you're supposed to create this that does whatever. and you go and you do it, you run the program, and my gosh, it ran the first time and there's no errors. Actually, sometimes that's a bad thing. All right, because first of all, it gives you a false sense of security. Well, geez, I can do this, and I know exactly what I'm doing. Then you do another program that's similar to it, and it's filled with errors. All right, so look at coming up with these errors as a good thing because it gives you a chance to learn, explore the language, etc. Now you might think, well, that's BS, but it's the truth. All right, so those are the three types, and again, they mention them in here. All right. So when you look at this this says that if I invest $10,000 over 10 years at an interest rate of 3.5, and if it comes back with like a 10,239,000, I want to invest in that bank. But there's a problem in there, and it's pretty obvious what it is. So as they mention here, you test to find all errors before you put an application into production. You debug to fix any errors you found while you were testing. And again, these are the three types of errors. So as they mentioned there, because sometimes these terms, they're confusing. Sometimes people use them interchangeably. To test an app, you run it to make sure it works properly, no matter what data you put in. When you debug, it's you found problems during testing. All right, those problems are known as bugs, and you try to fix them, and you rerun the application. All right, so as far as some common errors, and again, some of these you've already seen from me or yourself, there's a spelling error, query selector instead of query selector, omitting required parentheses. Now, I want to mention something to you. I want you to know this, and that is the following here. That if I sit there and type in this, let's say I type in if number grade, let's say we knew what the person's number grade was, is greater than or equal to 90, and we say letter grade equal A. And I could keep going. I'm not going to. All right. But what I want to tell you about this is if you write code like this, if you've got an if statement like this, if there is only one line below it, like we have here, it is not necessary for you to put in curly braces. I always do it anyway. In fact, some people will do it like this. I find that hard to read. All right. I like to sit there and break it up like I've shown you. Some people put their curly brace here. It really and truly, in the end, does not matter how you do it. All right. So I would write it like this. I think that's easier to read and it makes more sense. So I know that if this is a Boolean condition, it's true or false. So I know if it's true, I'm going to be doing everything that's in here. All right. To me, that makes more sense. Not everyone agrees with that. One of the things that you're able to do while you're here is to establish your own style. All right. A lot of times when you go to work for a company, they just expect you to do things in certain ways. I've worked for companies where they've given me basically their protocols. In other words, this is how we do things here. You're supposed to read through it, look at it, and understand it, and ask questions if you don't understand it. And then you're supposed to program that way. All right. Starting a thing with with a double quote and ending it with a single quote or vice versa. Now, with the omitting a semicolon, again, it's very rare that if you omit a semicolon, it's going to produce an error. Typically, the only time it does is things like if you've got a return statement, you know what those are now, and you leave it off of there, that can be problematic. Usually it'll work anyway, but sometimes it doesn't. That last bullet under common syntax errors is the big one. You've got to remember that JavaScript is a case-sensitive language. So as it says, misspelling or doing an incorrect capitalization of something either you've created, like sales tax that they show here, or something So if I did the word const in our program, I'm not going to go back and do that. But if I gave it a capital C, it wouldn't work. So it's very easy to introduce bugs into a program. All right. Sometimes, as it says here, the problem is not in your JavaScript, it's in your HTML. All right. What do I mean? Well, let's pretend for just a second. I'm not going to change this, but let's pretend in here I didn't set up an ID. So let's pretend that wasn't in there. So we've got type equal number, but I don't have an ID for it. Then I come in here and I come in and try to do this. Well, I'm going to get an error. All right, because it's looking for basically something with an ID of num2. I haven't provided that. All right. There's problems. Floating point isn't typically that big a thing. One thing I mentioned to people, sometimes they find this a little confusing, but math is not precise in a computer. So literally, in most programming languages, if I do this, 0.1 plus 0.1 plus 0.1, just gonna grab a cable, plus 0.1 plus 0.1, all right, and I'm just going to put another plus in here, and I'm going to copy this onto the next line, so you don't have to watch me type. But when I do this, you would think, well, 1/10 plus 1/10 plus 1/10, 10 times, that would be equal to 1. In most programming languages, it will not be equal to 1. In fact, in most programming languages, it'll be equal to something like this. Something like that. And that has to do with the way things are stored internally in computers. They're not precise. When you work with dollars and cents, they're not precise. Give you a real life example of this. Many years ago, I bought a car and I paid off the car, and I was waiting and waiting and waiting for the title of the car to be given to me. I lived in Wisconsin then, that's how it worked. All right. And I waited for like a month and nothing happened. So one day I get a USPS mail from the bank where I had taken my loan out saying that I still owed 6 cents on the car. They had some kind of a rounding error like this. So I paid the 6 cents and got my title. All right. But I'm just saying in here, when you are working with floating point types of variables, the math that's in there is imprecise. All right. Okay. Problems with undeclared variables, what I just mentioned to you. Notice here, though, it's again a capitalization thing. Sales tax with a capital T, sales tax with a lowercase t. Now, if you do that, and shame on me, I'm saying right now, shame on me, because I mentioned this to you earlier. What we should be doing is doing this at the top, at the top of every single program that we do. All right, well, I don't know why it's doing that, but what is it? Do I need to put use strict, all of it in there? I don't remember. All right. We should have use strict. Why? Because if I do this and I've got operator in here, and then later on I use it as operator with a capital O, this will catch it. If I leave that out and I put in here operator with a capital O, JavaScript by default will create a new variable called operator with a capital O. All right. So what use strict does is it prohibits basically that from happening. All right. The bottom line is, as they say on the bottom here, when the JavaScript engine in a browser comes to a statement that it can't execute, it throws an exception or an error. And then typically it skips the rest of the JavaScript statements. That brings up another topic. I don't know why I keep bringing that one up. All right. And that is this. All right. JavaScript is an interpreted language. What that means is JavaScript keeps executing your code until it finds something it doesn't understand. Then it stops, and typically, as the author said, it throws an error and/or an exception. Now, there are other languages, like the language we'll do next semester, those of you who are in C#, that are compiled. What that means is it runs through the whole program. If it finds an error, it ticks it off as an error, and it keeps going. JavaScript does not do that. I've given this example before. I don't know if it's a good example or a bad example, but I'm going to give it to you quickly anyway. We'll have two people here. We'll have Paul and we'll have Mary. All right. And they're meeting for the first time. Okay. And Paul only speaks English. And Mary only speaks Spanish. So they start talking to one another, and some words make sense, but most of them do not. All right. Well, the good news is along comes Anne, and Anne knows both English and she knows Spanish. All right. That's the good news. The bad news is she knows Spanish. She's from America. She knows Spanish, but you have to talk really slow for her to be able to get everything. So Paul talks in English. She goes and puts it into Spanish. Great. Mary answers in Spanish. Now there's a certain word that Anne doesn't remember what the Spanish equivalent is. So she says, stop, stop. She pulls out her Spanish to English dictionary and she finds that word. And then she's like, you can go on. That's what an interpreter is. All right. And when something is interpreted, it makes you stop when you get to a certain point if there's something the computer cannot understand. Most programming languages are compiled. That's why if I ran a program, the equivalent of a JavaScript program in C# and I had 10 errors, it would show me all 10 errors. Usually, if I did the same program in JavaScript, it would show me one or maybe two errors. When I fix them, it would show me the next one or two errors. When I fix them, etc. All right. All right. When they talk about test runs, what they're basically saying here is you should have a list of values that you want to test to see if something is working or is not working, period. Plus, you want to make sure that you know, I could go back, or we can use the one here, that if we leave one or more of these fields blank, we want to make sure that it's handled correctly as well. Just like if we left the height blank or the weight blank, all right, in our BMI program, or we didn't make a guess in our guess program, something like that. All right, so how to use the Chrome developer tools. Again, they go through this big thing with the F12. I don't know why, because to me, the easiest way of doing this is to just right mouse click in an empty area on your page, go down to the bottom and choose inspect. It is the same thing. So with the example they give here, what they've done is they got the is NaN. But when they do that, the is NaN, the last N is lowercase. All right. Again, simple syntax error. All right. Sometimes people find that, boom, not a problem. All right. So for opening it, again, closing it, you just click that X, etc. Now, how to find the JavaScript statement that caused the error. The big thing on this, and they'll say it in here someplace, is just because it shows you a certain line where the error is, it may not be right there. So if I've got a JavaScript program that's 50 lines long and it's showing me an error on line 17, really what that means is the error is somewhere between line 1 and line 17. Line 17 is where they found the error, but it could have actually been introduced earlier. But again, because of the fact that JavaScript is an interpreted language, It means it shouldn't be any later than line 17. All right. Okay. So as it says, the developer tools provide some excellent debugging features. All right. So let's take a look at a couple of those. All right. The first thing that you can put in there is a breakpoint. What that means is when the code is running. So that example that we had before. All right. Let's see. Let me bring this back up. All right. And let me put in another error again. All right. Let's see. We'll do the error that they did. All right. That is NaN. Again, nothing happens. I go over here. I go to inspect. All right. I go to console. Okay. And when I go in here, there's a bunch of different ways to bring this stuff up. But the point is, that's pretty obvious, right? I can go there. If I click on here, it brings up my code. Well, I look right here and I'm like, wow, look at that. Okay, that's the error. If I click on the number right here, what that just did is it put what's referred to as a break point into my code. What that means is whether that line is correct or not correct. All right, either way, it's going to stop right there. In fact, let's put a breakpoint here. Now, you can't put a breakpoint on a blank line. It doesn't make any sense. It has to be an executable line of code. All right. So you notice I've got these two breakpoints. So what would happen here is it would stop when I run it, and then I could come up and test anything up until that point. So I could go and look and see what the value of num1, num2, etc. were. All right. You turn it off the same way you turn it on. Now, again, it's pretty obvious here what the error is. All right. But breakpoints can be helpful when you're going in and you're debugging a program. Now, you'll notice just putting my mouse right there over where that red circle is gives me an even better description. Uncaught reference error is NaN is not defined. All right. I can actually go in, click right here, make the change, and do a Control S to save. All right. And it should be saved now. Okay. So you can actually change the code while you're in here if indeed that's what you want to do. All right. So let's go back. So they show you pretty much what I've just shown you here. They come in and they set up a breakpoint. So it says you can, this is an even better one. And if you remember what they showed you, in that video that we just watched, all right? Let me run it again. I'm going to put that error back in here. I guess it's still in there. All right, and again, just to make sure it doesn't work, and it doesn't. All right, if I come in here, this is what they showed on that video that we just watched, and I go to inspect. All right, and I go here to sources. All right, and I don't remember which one it is, unfortunately, but you can come in here. All right, there it brought that up. All right, and boy, I wish I remembered it, but it's not console. It is under sources, but it's one of these. Let's see. I don't remember if it's, no, it's not performance. Okay. Application, one of these in here. You can go back and watch the video. I'm sorry, I don't remember it. But what they show in the video is you can sit there and basically say, hey, I want to, they chose mouse and then they chose click. What that means is when you run the program, anytime you click either button, it's going to stop right there. And that would allow you to take a look at the values at that time. All right. And I will tell you, I gave you a really bad example yesterday because when we were working on this stuff, I was using alerts. All right. And alerts are temporary. Yes, they show you values. All right. but they don't hold the values. As soon as you close the alert, that value goes away. But that's about all we had talked about at that time, and that's why I showed them to you that way. So here's how to create and remove a breakpoint. Now, this is important right here. Again, this was explained in the video we watched, but let's go over them anyway. If there's a button there, or there's a thing there for step into, or as it says, you can use the F11 key. Now, what that will do is run your code one line at a time. So if you literally want to see how your program's running, you can keep hitting F11. Now, it's going to stop sooner or later. It might, and ask you to input something, or it might output something for you, but that's a way of doing it. All right. Then you've got step over. And, if I had something in there, let's say that I said I wanted you to print out all the numbers from 1 to 100. Well, if I did the F11, it would print out 1, then 2, then 3. I don't want to do that 100 times. So I might click step over, and boom, it runs through the whole thing for me. If I want to skip going through it, period, I can do a step out. All right. And resume, like I said, just goes back and starts running the program in a quote regular way again. All right. So as it says, you can take your mouse then and put it over a variable or a constant when you're in that code editor to see what the current value is. All right. There's also something in here, and this was shown in that video, that's called a watch. All right. So you click that greater than symbol that they show there, and then you click the plus sign, and then you type in the name of a variable that you want to watch as the program runs. Now, in what we're doing so far, that wouldn't really mean a whole heck of a lot because we're not really changing a lot of values in here. All right. As I mentioned, you can set up a breakpoint on any line, except not on a blank line. All right. And you get that blue arrow. So nothing new there. All right. I'm going to finish this and then we'll take a break. They give you a couple of other methods. So it says how to trace the execution. Again, this is the console log. And as I mentioned, there is a console log, there is a console warning, and there is a console error. The only thing, or console dot log, console dot warning, console dot error. The only difference between them will be the background color of what prints. But they give a good example here. They use a console log and they run that program, and you notice, well, this doesn't look too bad. It's going from 10,000 that we started with to 10,850 to this, but you can see it's starting to jump up really, really big. So as they mention here, this is a way that you can trace the execution of your program. As they mentioned, you can also use an alert, but the pop-ups are intrusive, meaning they're annoying. All right, that's what I used yesterday, but you can do it this way as well. All right, more methods for doing this stuff. Again, you can use the warning, the error, and the trace. So console.error, console.warn. I thought it was warning and must be warn. So you'll notice that the error is in a pink background. The warning, I said orange. I guess it's more a yellow background. All right. So those are more you can use. Also on the bottom of this page, they mention a stack trace. You might say, I don't know what that is. Well, if I run a program, let's look very quickly at the program that we have here. All right. So let's say that I'm running this program. Let's say I fixed all my errors. So I changed that back to NaN. All right. Now the program's running. Okay, it comes in here and I put in a number, I put in an operation, I put in another number. Okay. I click the button to calculate. So it comes into here and it does this. Says, okay, you got a number there. Okay, you got a number there. Okay, you've got an operator that you chose. So it says we're either one of those non-numeric. No, let's suppose they were numeric. So it skips that. So it comes down and it says, did you choose the plus? Let's say, yes, I did. So then this variable right here, result, is now going to be reset. I'm going to call a routine called add. I'm going to pass in num1 and num2 here. All right. So control is going to go from this function to this function. It'll return that, and it'll return control back to here. So now result is set. It's going to skip the rest of these because remember, with an if and an else, if and an else, only one can be true. So it does this. So what the stack trace is going to show is every single routine that was called in the program, not just your routines, but if some built-in JavaScript routines were called, it'll show those also. And it shows it in what's called a LIFO order. So the last one called will be the first one that's shown. All right. So it'll show them in an inverse type of order, is what I'm telling you. All right, we're almost finished here. How to view the HTML and CSS for a web page? Well, you know that. You right mouse click and you choose view page source. Nothing new there. But when you are in your dev tools, you can use elements, for example, and you can look at your HTML. All right. Console is typically going to end up being for your JavaScript. All right. Network is if for some reason the program was running really slow, etc. And those are the ones basically that we just deal with for now. All right. So they have a little bit about the elements panel. I'm not going to say any more about it. And that's it. So it is a little later than normal. So let's take a break. It is almost 9:07. Come back at 9:20. What I want to do then is to go over this test and go over what I'm looking for you to do, all right, for the rest of the period today. So I will see you at 9:20. All right, it is 9:20, so I'm going to continue on. If you weren't here for the beginning of class today, we watched this 7.5-minute video, all right, which is basically kind of a Chrome Tools, DevTools 101, as it says. All right, the demo for going along with that was right here. Also, I neglected to give you one of the URLs. I will send it out later today, but it's right here. In that URL, developer.chrome.com/docs/devtools/JavaScript, what they do in there is they walk through everything that's in the demo. All right, literally it's a hands-on guide. All right, so I'll make sure to send you the URL on there for that too. Okay, so that's the first thing that, like I said, that we did today. All right. What they reference in here is the Chrome DevTools documentation. It's very big, it's very extensive. All right. Part of the problem with trying to find really good videos on using Chrome DevTools for JavaScript is most of these videos are on Chrome DevTools, not just JavaScript. So they show a lot of stuff that you probably don't care that much about. All right. The other day I told you about that I had made a bunch of tapes and there was a thing out there on developer.mozilla.org on JavaScript. This right here is, as it says, has got common problems. This right here is W3 School's thing on debugging, and here's the thing I found on Stackify. So if I bring that up in here, this, like I said, this is that debug thing that we just watched the video on. We watched on about an hour ago. This is the actual demo itself. So this is where he put in a 5 and he put in a 1, and it should have came back and said 6 when you did this, but instead it said 5-1. And the reason it says that is we never do a parse int on either one of these, so it thinks they're strings. It's the string 5 and the string 1, so it appends the two strings together and it makes the string 5-1. All right. Then this one is what I mentioned. This is their documentation. Notice there's an overview in here. There is an opening Chrome DevTools, what's new, and these are all hyperlinked. All right. I am going to strongly suggest that you take this URL, which is the one I gave you right here. All right, right there, and you bookmark it or keep it open. And the reason for this is when you take your test, and your next test will be next Tuesday. When you take your test next Tuesday, all right, which is, I don't know, like the 24th or something like that. Most of the test is they give you a document and they say, hey, you were just hired as a programmer into this company because the last person was kind of a nitwit and they've got a bunch of errors in their code. So you have to debug it and find the errors and then make it run. And some of the stuff in there will include the other stuff, the arrow functions, event listeners, etc. All right. But I would strongly suggest you have that open so you know, if you need to, you can go back and use that. This I thought was an interesting article. It's a couple years old, 3 years old, a practical guide to JavaScript debugging. You know, what is it? And they go through a project. It's very similar to what we just looked at, but it's not the same project. All right. And like I said, I just thought walking through this, it was pretty decent. Again, you may or may not agree. All right. Then this was the one I mentioned from developer.mozilla.org. Common mistakes. Some of this we've already gone over before. All right. But look, what is an event? So if you're still confused about event objects or functions, etc., you could look there. And again, this was the W3 schools. All right. Thing on debugging. So like I said, you know, you might want to keep this open. You might even want to keep that open. I don't know when you're taking your test next week. All right. Now, I'm going to take the test myself, not right now, but this weekend. All right. And the reason for that is many years ago when I was teaching a different programming language, all right, I gave the class their first test. They didn't like it. They said it was too hard. So we went over a few chapters, and one of them was on debugging. All right. And I said, well, what do you want for your next test? I'm asking you. And they said, well, why don't you write a program that's got bugs in it, make us debug it? And I said, yeah, I can do that. But I will tell you, I'll put some bugs in there that'll be hard to find. And they were like, no, that's not a problem. They hated that test more than any other one they had. But you do have to learn the act of debugging. Everyone does. All right. And now, just so you are aware of this, we've talked about this before now, but I want to say it again. So let me move back up. Oops. So you are going to have a lot of time today where you can start working on homework. So if you have not yet started on that free code camp series, you can work on that, etc. But we have now gone through 5 chapters. All right. Next week, we will go over chapter 6 and chapter 7. All right. Not next week, but the following week, you will have a test that will be on chapters 6 and 7, really 1 through 7. That will be the last hands-on test you have for the semester. All right. So we'll be on around day 45 to 47 or something. And be like, well, what about the rest of the semester? Well, after we go through chapter 7, I talked about this. I had a meeting this morning with the other 2 AWD instructors. They don't do what I'm going to do with you. What is that? Well, after we take the test on 7, I'm going to lecture on all 4 of these in one period. There's no tests, there's no homework, there's no labs, there's no written test. So why are you going over them, Jeff? I'm going over them because after we spend a class period going over these 4 chapters, then we are going to come in and we are going to write a website together. You will not have to turn it in. All right. But it'll give us a chance to utilize the JavaScript concepts that are in chapters 1 to 7, plus the jQuery. All right. So that's what we'll do in a couple weeks. Then we will take another 1 to 2 weeks and we will go over this. All right. I will ask you to do the written tests on here. There may or may not be homework. There will not be any hands-on tests. All right. But we'll spend 1 to 2 weeks on that. And we're going to write another website as a class. All right. Then rather than going on, we will do this, but not next. We're going to go into a different subject that is not in your book. All right. Because Mr. Gudmested, who runs the program, has said that he thinks it's a good idea that students in this class get exposed to a free software package called React. React is used quite a bit in your 3rd semester class, AWD1111, Database-Driven Website Development 1. So we will create a few React apps for a week or 2 or whatever it takes. Then we will come back and finish up the book. When we finish up the book, again, there will be, just so you know, there will be no tests, there will be no homework, there will be no written or hands-on tests, but that will get us through the book. In an ideal world, that'll give us, that'll take us till about the last week of class. Then what I try to do for that last week of class, and just so you know, that last week of class is not that far away. Next Monday is day 40, so we're halfway done after next Monday. The last day of scheduled day of class is right there, December 21st. So what I hope to be able to do is for the 18th, the 19th, the 20th, and the 21st, they will all be lab periods. By that time, we will go over again what you have to do as far as creating this, creating your electronic portfolio for the class. We will go over that again. I will show you again how you can save it out to GitHub Pages, and I will show you also how to put it out to Netlify. All right. It'll be expected that you will have that turned in. All right. Since I'm giving you all of that time, then the expectation is the last day of class, we're talking noon on that Thursday, you will have all work turned in. Not by midnight that day, but by noon that day. Why? Because by no later than noon on Friday, the 22nd, I have to have grades in. All right. And some of this stuff can take a while to grade. Not only that, they prefer it if I have all of my stuff in by 8 a.m. on the 22nd, not by noon when it's mandated that we have it in. Also, we have end of semester meetings, and there's a bunch of paperwork that I have to fill out on the last day or two of class. All right. So again, do the best you can to go through the stuff that I just showed you in this pretest. After you go through this stuff, go back and see if you can rewrite the BMI program and the guessing game program using arrow functions and event listeners. On Monday, that's what I'm going to do. I'm going to go back and I'm going to rewrite the BMI and I'm going to rewrite the guessing game, and I'm going to rewrite both of them using arrow functions. All right. I don't have any idea how long that'll take, but I don't want to go on to chapters 6 and 7 and beyond until we have our test. That's why the test, I mean, I could just give you this right now and give you the test on Monday. I don't want to do that. All right. But we're doing really well in here, I think, at least time-wise. We're keeping up, with the class that's in St. Louis. In fact, we're about a chapter ahead of them. All right. So that's all I had for today. Please, if you haven't done so, yesterday, your chapters 1 through 3 work was due. What's that chapters 1 through 3 work? It's doing that fast food application, and I did that for you in class. Rather than that being worth 100 points, it's only worth 10 points. And you were supposed to complete 40% of that free code camp JavaScript class or whatever you'd call it that's on there. Then for this week, all right, for chapter 4, you're supposed to go and create or finish 20% more of the class. So you're 60% done. And then the other one is you're supposed to do 20% after that. So you're 80% done. All right. I have been trying to supplement that stuff by giving you things like the BMI game, the guessing game, etc. All right. So you're not just doing stuff from a website someplace. Again, somebody else made that determination that this is the way this class was going to be taught. I'm not saying it's right or wrong. I'm just telling you that somebody else made that determination. All right. So it is 9:30. It's way early from where we usually are, but I am finished for today. All right. In fact, what I'm going to do right now is I'm going to go back to my copies of the BMI and guessing game, and I'm going to rewrite them right now using arrow functions and event listers. All right. So with that, tomorrow again is lab, so I will talk to you Monday at 8:05. I'll see you then. Have a good weekend.